So in this video we're gonna study after so we concluded our video at memory hierarchy. So from this video onwards we're gonna study and the crash course about registers. So uh, so introduction part is covered. So in this video series I gonna cover about all about the registers. So yep, it's gonna be 3 or 4 or 5 videos for small durations like 5 minutes or 10 minutes, and it's gonna cover all our registers for your examinations. So what is registers? So in digital electronics we studied about registers. So if you study about flip-flops you have also studied about registers. So uh, what you can say as registers are a place where you can store some data. So if you don't study about registers, just understand it in this way. So there are many type of registers. One is address registers, then there is data registers, then there is instruction registers, then there is program counter, accumulator, and temporary registers, and input and output registers. I have not written it here, but please include it. I have written it here like input registers and output registers. So let's start from the input registers and output registers. So it is a register in which we save the input or output. So uh, not start from here, let's start from this part. That is, we taken a registers example, that is 4096 into 16. So if we write a register like this, it represent a register, that is 4096 into 16. So what it means, like we here is a register named, that is 4096 into 16. So registers are represented by this annotation. So what this annotation shows, if we see carefully, it is nothing but uh, if we write it in 2 to the power 12 form. So we know that 2 to the power 12 is nothing but 4096. Okay, so and there is 16. So 4096 is the memory location. Okay, ML, the memory location of the register, or I can say memory address, and 16 represent the bit. So in a part of this register we can store 16 bits. So here is example that it is a memory, like it is a register. So here is many other parts, I have shown some of them, but it is 4096 and I represented it in 2 to the power 12 form. If there is another number that we can represent in 2 to the power n form, it's not 2n, it's 2 to the power n. So 2 to the power n, and n is called the n bit. So it is 2 to the power 12, so it is 12 bit register. Okay, and in every bit we can save 16 bits of information. So 16 represent how much data we can but we can store in every bit. Like there is 12 bits, and in every bit we can store 16 bits of data. So I hope it is clear. So from this part we gonna study the different type of register, that is address register. So this register stores the address of memory. Like if we write n and we represent it as not 2 to the power 12 but 2 to the power 3. So for 2 to the power 3 we're gonna write like this: 001 00, oh sorry, 0000001, then there is 010. So from this onwards, from 2111 for 3-bit register, not 12-bit register. For 12-bit register there is 12 zeros. So if there is n and n is stored as this first place, so the address of n is nothing but 12 zeros. So from this part we understand that. like in which address the data is stored, that is address of the memory. So the register that shows the address or that stores the address of the program or of the memory, address of the memory location, so it is called as address registers. And there is data registers, that is 16-bit. So it shows the register that how much the register can store, uh, how much data the register can store. It is represented by data registers, that is 16 bits. Then there is instructions registers, like the data we have stored is like there's a data that we written in English. Okay, so there's I written registers. If we write registers in computer machines, it first gonna turn it into the binary code. First machine language, then binary code. So we skip the machine language. We assume that registers is directly changed to binary codes. Okay, so binary code is nothing but the data. Okay, so the register that stores the binary form of the data. Okay, so that is called instruction registers. Okay, so it is, as it is storing the data only, so its size also is 16 bits for this case study. Okay, we have take a register, the real life registers, and then we are understanding it one by one. Then there is programming counter. It shows the next instructions. Okay, address of the next instruction, so it's also represent the address. And we know the size of address is 12 bits, so the size of programming counter is also be 12 bits. So then there is accumulator and temporary registers. So if we perform any arithmetic operation, it generally done in von Neumann architecture. We have seen that it's generally done in ALU part. So here it is. We can see that any arithmetic part, any arithmetic logical part is generally done in ALU part, arithmetic arithmetic logic unit. So yep. So if we done any arithmetic thing in our computer, so the first part goes to the accumulator, the initial part, the primary part goes to the accumulator, and the secondary part goes to the temporary register. So let me discuss it further. Wait a minute. I'm gonna discuss accumulator in details. Okay, so if we see in this section, I've written that accumulator in arithmetic operation, the memory location of the intermediate value, that is a plus b. So the intermediate value is a. So a goes to the arithmetic register. So in the register in arithmetic operation, the memory location of intermediate values stored in where accumulator, and the secondary value or the temporary value, the memory location of the temporary value is stored into the temporary register. Okay, so and there is input registers and the output registers. So the generally the input is stored, the location of input data is stored in input register, and the memory location of the output data is stored in output register. So yep. So here I conclude the registers, that is this type of register including input register and output register. Address, data, address shows the address, data shows the data, binary form of the data is instructions, programming counter shows the next instruction address of the program. Okay, so as it is showing the data on address only, so it is 12 bit. Then if there is accumulator, a is accumulator, B is temporary because initially it is A. If there is B plus A, so B gonna be accumulator and A gonna be temporary. And the address, the memory location of the input data is stored in input register, and for the output, that is output register. So if the register is completed, uh, so from the next video onwards, I am gonna cover the buses.